I feel like we were supposed
Okay, everybody. Few announcements, and then we'll jump right into our lesson today. No, I can't even remember what I was going to say. Okay, number one, corrections for Unit 3, reminder, are due this Saturday. There is no retake for either test. You just have to turn in your corrections, and you'll get your points back.
Yes, we're so happy you're here. That's why we were glad.
I was like so happy.
Evan's here.
I love my hydro flask.
Oh, that's the bad. Yeah, gotta go back to the hydro. So. With that being said, though, I will be looking more detailedly than I do at your corrections. I'll be honest, normally because there's a retake, I just glance through corrections, but I want to make sure, because remember that Unit 3 is weighted heavier than all the other units on the final AP test.
Dude.
So we do need to make sure we understand these things. Okay, it's about, they say about, for the final test, about 15% of the final test comes from Unit 3. All of the other ones are like 8%. So we definitely want to understand intermolecular forces. So if you need help on your corrections, because you're like, I don't quite understand why I got this wrong or why that's the right answer, please reach out. Okay, please get the help you need so that we do understand it. Okay. Second thing, just a reminder, precipitation labs, get those finished up and turned in online for that as well. So, any other questions about things?
When is the retakes due?
Saturday night.
Okay.
So, yeah. Any other questions about Canvas or stuff as we're finishing up the term?
What days are you here after school? I forget it.
Just on the days I teach.
Okay.
So, if I'm, so Tuesdays and weekdays, yeah. Tuesdays and Fridays, so. Yeah, feel free to come in today after classes if you want.
Okay.
So, and it is, obviously it wouldn't work for like Unit 3, but next week, like last day I'll see you is Tuesday, right? But on Friday, I am here and you're welcome to come in next Friday.
So
It'd be like for like Unit 4 stuff, if you have questions like about labs or things like that that you don't have for the term, you could come in that Friday. But
when is this lab?
the precipitation lab,
No, that one.
the one we're assigned tonight, I think I'll have to open all the way through next Wednesday. So you do still have a week for it. So yeah.
When is our test for Unit 4?
So Unit 4, you'll take. So we're learning today. We learn Friday. Tuesday's our last day of the unit, and you'll take it Wednesday through Friday at most. So, the big thing is though, and for most of you are fine, but some of you have issues taking tests on time.
Wednesday.
I'm not saying names.
But it needs whatever it is.
But Canvas, just because of the term, I'm pretty sure Canvas won't let you take it after the term ends, because Canvas will close it. So you've got to take it before, which is going to be better for you anyways. We go on break, okay? Okay, pull out your note packet for me, everybody, and let's start with a smiley face question. Pull out your note packet and turn to page 6.
I think I well, I mean, how to do
You just have to figure out how to do this, and then the strategy.
Like people dedicate their whole life to it. It's actually pretty epic. It's pretty epic.
Okay, let's put other distractions away. And if that means you gotta pull down your blinders so you don't see your neighbor, that's fine too. They're your distraction. There you go. We all just wear clips so we can't see. Okay, for smiley face, but on your own, so I don't want you to talk to your neighbor on this one. Okay, complete this reaction for me. So this is my before, that's my reaction. Draw for me the after picture. Ready, set, go. Don't talk to anyone though, I want you to think through this one by yourself. your pencil down when you're done drawing so I know you're finished. Now for the lesson today, I'm going to be using a variety of colors on the whiteboard in a with very particular reason in how I'm setting up these problems. I think I mentioned to you before that often when I would take notes in college of a multi-step type thing, I would do each step in a different color. That way when I got home and looked at my notes, I understood, okay, I did this, and then I did that, and then I did that, rather than just seeing the puzzle together and being like, shoot, how did I put this together? So if you have different colors of pens or pencils, I recommend maybe doing the same thing. Or I have colored pencils you're welcome to use as well. But just know there's a reason to the colors I'm using on the board and I'm going to talk to you about. But for this problem, you should have, so these are nitrogens, these are hydrogens. The balanced equation tells us how things react. So the reaction says that one nitrogen needs 3 hydrogens. So in these particular views, what I like to do is kind of line them up and say, okay, well, one nitrogen needs 1, 2, 3 in order to react. Which right away tells me that I should have 2 excess
Go.
in your final picture. Then you're going to have 2 if you have that, you can have a smiley face here. Okay? Now, what's important to recognize here, everyone, is the balanced equation tells me the ratio is what is needed. You can have more than what the ratio has, but there is a problem if we have less. Let's say hypothetically they gave you a box with only 2 hydrogens. Would a reaction happen?
No.
Right? You've got to have the minimum in order for the reaction to go. But you can always have leftovers, and that's fine. Okay? Today we are learning about something that in chemistry we call stoichiometry. Stoichiometry, I love the word because it sounds really fancy. And when you tell people what you did, most people have no idea what it even means. So you can sound extra smart, right, by just having a fancy word. Say like, Mom, I learned stoichiometry today. And she'll be like, what? At least most moms. Your mom probably won't know what it is, but no. But the whole idea of stoichiometry we've already done. Stoichiometry is the process of converting units. It's just saying, okay, if I have this much of this, how much of that is going to be me? What I'm going to start off our lesson with first is we're going to do a demonstration along with the math. The hope is I want you to try to bring to life the problems you're solving. Don't memorize the process. If you understand how these things are related and how they change, stoichiometry is really cool and actually like, oh, it's not as hard as it looks, okay? So let's look at our map here that will guide us in our different relationships. A little bit bigger than the map we've looked at before, but the idea is still the same. This helps us understand how things are related and how they're connected. What I recommend is if you're stuck on the homework, use the map. Eventually you're going to have to do it without the map though, because you don't get the map on the test. But the more you practice it, the less you should need it. Okay? Alright, let's fill in our relationship. So this one we've used hundreds of times. What connects grams of something to moles of something? There it is. Molar mass. I heard someone say it, but where do I get the molar mass from?
The periodic table.
Periodic table. Good. Now notice we have the same relationship on this side, moles to grams. This one we've also used fairly often. What connects moles and particles together?
6.02.
There you go, Avogadro's number. And that number is on your formula sheet, the one where I said the 6.02 times 10 to the 23rd. Okay? Okay? This one, so this connects liters of a solution to moles of the solution, which is molarity. Literally the equation for molarity is moles over liter. Obviously same thing on the other side. And then our relationship at the top, now this is where you gotta be careful when you do problems because they're both the unit of liter. But this is for a solution, this is when it's a gas. So for gases, we use that, there's 22.4 liters in every 1 mole. It's just a standard relationship. And I think that's even on your formula sheet too. So. Okay. Last arrow, the thing that connects our given to our unknown. The key to how chemistry works is through the balanced equation. The balanced equation helps us understand if I have this much of this, I'm going to need that much of that. Or if I pour this much in, I should get this much out. Okay? Okay, I'm going to leave this screen here as we go through our demonstration problem just so we can use the map. But if you want to turn your page to where it says carbide can in here. So the reaction that we're doing is we're taking some calcium carbide and we're going to put it in water. In the process of putting it in water, it's going to make this compound known as acetylene gas. And the solution will have some calcium hydroxide in it. So that stays aqueous. This is a gas. This is a solid. That's liquid. Okay? This right here is the calcium carbide. It looks like gravel, pretty much. We're going to put these rocks into water to make our acetylene gas. Here's what it looks like. Once again, we're going to bring to life the problems. We don't want them just to become story problems where it's just math, right? Okay, question number 1 says, if I have 0.5 grams of calcium carbide, how many moles of acetylene will be made? Now, as always, what I recommend is you underline what you know and circle what you're trying to find. So everybody underline that 0.5 and circle moles of acetylene. Next step is you go to your map to figure out how many steps it's going to take to get there. So I'm starting in what? Mass in grams, and I'm going to moles of something different. So this is going to be a 1-2-step process. Okay? So step 1 is you take what's given, and we have to convert it into moles. So set up your fraction. Going from grams of calcium carbide to moles of calcium carbide. Actually, I'm going to change that color here. What connects those two things? Oh, good. We're all looking at the periodic table.
64 point something.
64.7.
0.089.
0916.
0916, so we'll
Yeah,
just go
I'm-
0.10.
Yeah, wait, how can you?
Yeah, how can you read that, dude?
I mean, I can read the closer ones, it's like hydrogen and calcium.
Wow, some of you.
Dude, you just got that really good eyes.
He's a hawk.
He's a
One
snipe.
in vision, you know.
Okay, so we got 1 mole for every that many grams. Questions on step 1? So on our map, we travel from here to here. So step 2 is we gotta go from here to there. So set up my next fraction. Okay, moles of calcium carbide will go on the bottom. And I'm trying to change that into okay. Balance equation tells me that for every one of these, it's going to make one of those.
Oh.
Now, obviously mathematically that did nothing. But it's extremely important to look at that multiple step, see how they're related to each other. Because honestly, most of the time it's not going to be 1-to-1. Okay? Now, another thing I want you to notice with our setup. The only time you can have 2 different substances is when you're comparing them by the mole. You cannot compare moles of one thing to grams of the other. Or in a sense, there's no airplanes on this map. You can't fly from here to here without thinking through this step first. It gets really messed up if you start trying to just skip steps because it's only connected through the mole step. Okay, plug that in and we get
0.0078.
7/8.
Yeah.
Thanks, Tyler. I guess technically sig fig wise, I only have 1, huh? We'll just say 0.08. Okay, so what we just found is that if I pour in, so this is 0.5 of a gram. If I pour that into water, I'm going to make this many moles of soap. Alright, let's see it happen. Now obviously there's another side to this because hence the name carbide cannon. Acetylene gas is explosive.
Yay!
So after we make it, we're gonna light it on fire.
Yes.
This is why I love chemistry.
See why chemistry is great.
Why would you just make a gas and not light it? Okay, I'm doing 70 milliliters of water. Now the way my cannon works here, everybody, is I'm going to put the rocks in there. I'm going to put a bandana on top to trap the gas. Okay? I then have a small hole in the side of my bottle that I'm going to light for the cannon. Okay? Sorry, I gotta make sure it fits good before I don't want to let any gas escape. Yeah, that's why I'm using a bandana and not capping it, because that would be called a bomb. Okay, that seems pretty good. Okay, everybody ready? Now, it's a little dirty, and I guess if you couldn't see the periodic table, you might not be able to see this. But, if you look carefully, you'll be able to see the gas being made, because the rocks will actually start like bouncing around in the water as they're making the gas. So. Okay, so this is 0.5. I just measured it out before you got here. In there. Hang on, I'm going to give it some time to make us some gas before I light it. You can kind of see, I don't know, Aaron can maybe see the bubbles. Yeah.
So rice.
Bryce can see his butt.
It is the same.
Top guys.
Eagle eye.
She's all the atoms.
Yeah,
I think the watch.
Okay, here we go. In 5, 4, 3, 2, 1.
Oh my god!
He just like falling out of her chair. Sorry, I should have warned you.
I felt like a shockwave. All I hear is just like,
I told you it was a cannon.
It sounds like awkward.
I don't want to sleep. I should have done that. Okay, so there you
Do it
go.
again.
Okay, let's look at problem 2.
See, but this one is 5 grams.
oh, it's awesome.
We're gonna get an example of 5 grams.
Okay, ready? So number 2 says, if 5 grams of calcium carbide are put into a second bottle, how many moles of acetylene gas will be made?
Yeah, she's got a second bottle.
Very explosive.
Okay, turn to your table, buddy, and solve this problem.
All
Go.
of a sudden, we went from
Alright,
0.5 grams to 5 grams.
Oh, you just
Okay, so it's
Basically the same
how many moles? Yeah, it's literally the exact same thing.
Do you want to know? Do you want to know to make it easier to have one? I have extra, but it's up to you. And then you just combine the 2 packets together.
Oh yeah, can I have one too? I should have mine. Just a note jacket.
Have extra.
Really, all I have to do is delete a decimal.
Yeah, that's it.
Yeah.
that felt weird.
I think it's
It does, yeah, it's not good.
Okay, do we have an answer yet?
Wait, we're doing 5? Doing this? This is gonna be insane. We're gonna get the prompts called on this classroom.
Yeah, you just put me over.
Oh, let's go. Let's get ready.
Except for,
I guess they're probably
we need 0.07.
Yo, Taylor, what did you get?
I got
6 big.
Point of
C
zero.
A C
Yeah, look at
C.
Oh yeah, because this is 5 by 10.
Whoa.
So,
Once you have an answer to number 2, go ahead and read and answer number 3 for me.
Oh, really?
Wait, 0.78.
ah, this is gonna be a letdown. This is gonna be a letdown.
I don't know why that doesn't make any sense to me.
It just feels like it's going to be,
Because they're asking.
Because they're asking the question.
Yeah.
You're gonna lower your expectations and the whole room is gonna
Wait, what?
Yeah, we're all gonna die. actually.
It's asking if the first bottle would have.
Well, I mean, it's the same amount of water though.
It's saying which bottle would have a bigger
Oh, no,
percentage.
The big.
Okay, I'm doing 70 milliliters of water again.
That's
I know that.
Is that what?
But then why would it guess that? Why would it ask that
I don't
question?
know why it would
if
go down, but I have a feeling it's.
Yeah, it's gonna be like there's not.
Okay, first off, you should have gotten 0.08 moles if you got that out of smiley face.
Yeah.
Wait, aren't there 2 sig figs for that one though?
Oh, I guess so. Huh, 'cause
It's 5.0.
That's right, you do get 2 sig figs, so what,
I-
0.078?
Oh, 70.
Dang it, Taylor.
Technically, did you have to do much stoichiometry really to get an answer?
No.
Right, because we're doing 10 times the amount, the answer obviously would be 10 times the amount.
It'd be bigger because you would make.
But, okay. Everybody ready?
So different.
Okay,
aim
so
this
here's the
one at
5
Evan.
grams.
Oh my god,
Okay.
we're done. We're
Can you
done.
aim this one at Evan for me?
Hey!
No, I think that makes sense.
He just ducks out of
That makes sense to aim it at Evan.
Yes.
Yes.
You're gonna be like at the camera to like
Oh,
blow
I
it.
could just.
Yeah, but you can take it out of all of
You're gonna
us.
see how that looks on camera.
Yeah, I think Evan can take it. He's a man.
Alright, this one, more people should be able to see the bubbles being made.
Ooh, that implies more.
Oh,
Oh,
I
I
did
do.
see it.
Oh, I see.
Oh. Hey, I just
No,
said
Evan, your head is in the way.
We need to prepare again.
Thank you, Evan.
I'll count down.
You probably now.
I don't know.
Evan, you're good. You're good.
Oh, I see the bubbles.
My bubbles. Oh, that was a Nemo.
Okay, ready? 5, 4,
Oh,
Three,
Bracing
no.
myself.
two,
It's not even gonna be that bad.
one.
Yeah.
Lame.
Nothing except a fire, but no explosion. Okay, you tell me why.
No, you tell me why. I was let down. Would you owe us an explanation?
Okay, turn your tail, buddy. Figure it out. Why did we make more acetylene?
Yes.
Why did we not get the explosion you were all wanting?
Maybe.
Turn your tail, buddy. Figure it out.
Yeah, maybe.
But like,
I don't know, it's just.
Well, she's talking about how like the whole
That doesn't make sense to me. Because you do all to the gas, it's explosive.
Sorry, the slightly burned bandana is coming to attack you.
Yeah, we should have found out on this.
I think there was.
And sorry, you guys might get away with it. This is kind of a steamy gas.
Yeah, I think that was just a connection.
It's the burn, Zach, it's a different thing. It's the burn.
He doesn't always light on fire like that.
What? So I think it is. So it makes calcium.
So it's saying
Figure it out. Why do we not get the boom you were wanting to? Or what do I need to change so we could get a boom that you
wait, is it the same amount of liquid?
More water.
I did the same amount of liquid.
Oh.
Yeah, that's it. More water, y'all.
Wait, that doesn't make sense.
It wasn't like we ran out of water.
I don't know. It's just not balanced.
it may be the liquid or it
It's
may
not
be
balanced.
the. Oh, yeah.
I don't know what that means exactly.
Me
It's
neither.
not
It's
balanced.
not balanced.
Person's not playing you guys.
I don't know, though. This is kind of stopping.
Or perhaps it's because.
Okay, let's hear. Let's hear some thoughts. Why? And I know I tricked you. It's part of the whole plan. But why did it not work like you originally felt like it should? Because I saw your faces when I said we were doing 5. You guys were like, we're doing 5 grams? So what happened? What's going on there? Someone help us understand.
Is the hole bigger in the second bottle?
Ooh, nope. The about same size as a hole, but not a bad question.
Not
Have a smile face for that.
water.
Other thoughts?
I think that maybe you didn't give it enough time to react
Ooh.
because there were 5 grams and you gave it like 5 more seconds, and I feel like it wouldn't have reacted fully.
So you're saying, okay, let's build off that. Have a smile face because it's not a bad thought. It's a wrong thought, but not a bad one.
It's a wrong thought.
So, how many moles did I make the first time? So technically, as soon as my reaction made this much, should it have gone still?
Oh yeah.
Yeah, that's.
But not a bad thought, Taylor. Max?
Is it because the second one took longer to react, and so then the pressure of the gas wasn't there as much? Because my thought was that maybe there wasn't enough oxygen in the bottle to react to combust immediately, so it was like reacting as soon as it could get outside where there was oxygen. And then for the first one, there was enough oxygen in the bottle to react, so when you lit it, then it instantly got lit.
Good, have a smile face for that. Bryce, we're gonna add something different.
I was just gonna say, like, since there was more gas in the bottle, it might be like it'd be bouncing around more, and so it could have a higher speed, which would be causing more particles to get out of the hole.
So kind of combination of both. So the first thing here that I want you to show with stoichiometry is stoichiometry depends on the ratio of everything there. I heard a lot of you bringing up the idea of the water. Maybe there wasn't enough. That's not a bad thought, but there was plenty of water. Water in this reaction is what we would call the excess. I just put in plenty so I knew I wouldn't run out of water. But the explosion is based on having enough oxygen. What happened is I made so much acetylene, it pushed all the oxygen out of the hole. So there's only acetylene in my bottle. And acetylene without oxygen can explode. It lit because of the oxygen right by the hole so it can catch fire, but that was our issue. So So as we do stoichiometry problems, that's stoichiometry in real life. It's this idea of you need the right ratio, otherwise,
But like if you had a bigger bottle.
there we go. So that's how we fix the problem. We get a bigger bottle.
So do it in the gallon. In the gallon.
Yes.
No.
She knows what's gonna happen.
We
Yes,
can
sir.
go outside. You can go
What?
outside and do it.
Social distance.
We'll light a few.
Then you can close the top of
Okay,
all.
but here's the problem. I have to
Light
hold
a
the
fuse.
bottle. I don't want to be next to
No,
that.
we'll take it down.
No, you
No,
can
no,
close
no,
it
no,
and then just throw
Like
it.
a fuse.
I can have like a chicken stick and light it from a distance.
No, we'll have like a string that's a fuse.
Yeah, we'll
and
just get a
light the
string.
Oh, yeah.
Oh,
yeah.
we'll take Evan's jacket.
Why?
Cut it into strips. And then,
Okay, I'll
maybe
think
use
about it.
that. I don't know.
I gotta think through. I always practice safety. Like I do these things before you're in the room to make sure they're safe. So I never want to do an uncontrolled experiment because then I'll end up like on YouTube as one of those videos who like catches their students on fire. So
Yes. That is
Yes,
exactly. You know how many See, I'm in a YouTube video and I have no views. If I was on fire, that would-
Purely theoretically, if you got like a big Home Depot bucket and then you did the reaction but like with a pumpkin in the top, would it shoot the pumpkin out?
Oh, that would.
Whoa.
Yeah.
So I've seen people make like potato cannons with this reaction, like a big PVC pipe and then put a potato and then you do the reaction and it launches the potato. Yeah, I mean theoretically it should because it's just building up pressure.
But I mean, the pumpkin probably wouldn't hold it in very well.
Yeah, I don't. Yeah.
Unless you make
A pumpkin would probably just
shaped bucket.
a hole in your
Okay. Question so far. So as we continue to go through stoichiometry, everyone, like that's what it's all about. Oh, let's do a few labels here really quick. Okay, so in our second reaction here, the oxygen is what we would call the limiting reactant. It limited the reaction from happening because we didn't have enough of it. Okay, once again, another term is the water was in excess because you had more than what you need. Sometimes you'll get the perfect amounts because you don't want to be wasteful, right? So you figure out exactly. Sometimes when things are cheap, like water, you're just like, well, let's just put in extra to make sure we don't run out. So this would have been the limiting, and this was the excess. The limiting prevents how much can be made. Okay? So as we look through our stoichiometry, it's all about that ratio. Now, depending on how well you can understand and visualize ratios, kind of determines how much you might need to write in solving problems. For example, let's look at this next one here on your notes. Okay? This one has a lot going on, and we want to know how much of one of the things is necessary if we're given the amounts of the others. Let me get rid of this really quick. Now, one way you can look at ratios is by setting up what is known as a rice chart. A rice chart is something we'll use later on that's like really, really helpful. For now, it can just help you if you're stuck. Sometimes you can look at it and just see, okay, I'm going to run out of this first. But if there's a lot going on, the rice chart can kind of break it down for you. So what RICE stands for is reaction, initial, change, and end. Once again, this is just a problem-solving technique to help you look at ratios for moles. Side note, RICE only works
What did it stand for again?
Really
With
important,
moles?
cool engineering.
Okay. Really important. Cool.
and I guess pressure as well. We don't really deal with pressure a ton in this unit, but it does also work with pressure.
Wait, what does it stand for
Oh,
again?
reaction.
Yeah.
So next to R, we're going to write the reaction. So we have 10HI plus 2 potassium permanganates
That's you?
plus 3 sulfuric acids.
Hot. That was a chemical. KMNO. KMNO. That's
Amino.
Amino. But also, there's no L. You know, LMNO. There's no L. It's
Oh
just
no.
M and L.
Oh.
What are you gonna do, Taylor?
Okay, I is for the initial conditions. Oh, sorry, I'll give you a second to keep writing your equation. It's kind of a long one.
It is.
You know, I actually met someone named KML, and their name was pronounced Noel.
Yeah. Then there's SSSST, Forest.
Okay, step one with the right strat is to write the reaction. Step two is to plug in the information that is given. So in this problem, what information is given here?
The formula.
Produce
Oh,
2.5
moles.
4 moles.
2.5 moles of I2.
Good. Now the question is this a starting amount or an ending amount?
And then.
Ending.
So that 2.5 should go by the E line. Okay. What else is given?
4.0 moles of KMNO4.
It's pronounced Camino.
Okay, so we're gonna put 4.0 as an initial.
Or second.
This one they tell us is 3. This is the goal, so I'm gonna put a question mark, that's what I'm trying to find. Because I wanna know how much of this is needed to make that amount given these other things. Now what that means is all of this doesn't really matter for our problem. We don't care about those because we're just not asking about it.
But like, is it possible like you would need to like solve for some of that stuff?
Possibly,
Fit
not
the
to
problem?
solve the answer, but if they wanted something else, it totally could come up. It's like a part B to the question.
So we wrote that.
Now, we do know this as well.
We do?
Oh, I put an X on.
What's the initial amount of that?
Oh.
0.
Ooh.
Why would it be 0?
There's no
The reaction hasn't happened yet,
Oh.
right? So before the reaction happens, you don't have any of this,
Oh.
because it's being made.
That one took a lot.
That
Okay.
took way too much time.
Okay, so step 1 in blue, I just plugged in all the initials. The next step is using the given information and the change, you should be able to fill in the rest. Now the key step with the change step is things change based off the ratio of the equation. So I know, just because of math, if this was 0 and this is 2.5, that this had to increase.
Well,
By
oh wait,
2.5.
yes, it was. I was like, that doesn't.
I fill in the blank.
Oh.
Now,
Oh, and all
Look at
those
this,
other
everybody.
things minus.
the change is based off the ratio.
Oh.
So this is 2.5, which is half of that number, right? Which means all the others will change by that same ratio. So that
So
means
it's
this
half?
one's going to change by
1.
Oh my.
1.5.
That's ridiculous.
What?
Wait, why is that ridiculous?
I was making.
Now the difference is, does the reactant amount go up or down?
Wait.
It ends with 2.
So it
and-
should be minusing because it's reacting. How much is this one gonna change by?
2. Well, no.
Now careful, did the ratio change by this amount or by the ratio amount? Ratio amount, right?
Oh.
What? So it's just 4.
Oh, because there's 2 K.
Sorry, let me say that again a different way, maybe. I think I said
I
that.
didn't even know.
It's gonna be 1?
So we're changing, so this one started with,
Wait, that means that it's just
how do I
4,
put that a
right?
different way? This one changed by 2.5, it increased by 2.5. So that means that that's how much was made. So the ratio is, it increased by 2.5. So this is a 2 to 5 ratio, which means this number should reflect that same 2 to 5 ratio.
So it should be
What?
so
Wait, why is it a 2 to 5 ratio?
it's 2.5 to 5.
Because it's 2 and then you go.
I thought it was like 1/2.
So it's like like you can set it up as a proportion if you can't see it, so it's like 2 over what is the same as 5 over 2.5?
Oh, and then you do the fishing method.
Oh.
So it's just one.
So 5x equals. Oh, so it's just
5
1.
divided by
Yeah.
5, what?
Oh, so it's half of the number on the side, not the number underneath.
Wait, now I'm-
Yes, because it's based off,
Okay.
the change is based off the ratio. This is not my
Yes.
ratio, this is just
Okay.
what I have.
That makes sense.
Does that make sense?
Yeah.
Yes.
Okay, now, so how much is it changing by?
One.
So
Minus
it's
one.
by amount of 1, right?
Yes. and
So
then
the
that's-
ratio of 1 to every one of those, right? Okay. Okay, what about this one?
5.
Oh.
Okay, good so far? Now, what is the goal we're trying to find?
10 HI.
BE for 10 HI.
How much of this is necessary? So if we know it's gonna use up this much, how much is necessary?
That much.
Just that much.
Oh.
So the answer is, we need 5 moles of HI. I could have more, but the
Wait,
minimum that's
because
required
you don't need
is the
any more than
change.
The amount that you're subtracting.
Because as long as I have 5, will I make that much?
I'm gonna guess, yeah, sure.
If I had less than 5, would I make it?
No.
Could I have more than 5?
No.
Yes.
What is the
Because
Oh, yeah.
none of you didn't-
Is the end, like how much you have in the end. So another problem could ask and say like, how much excess do you have, right? And we'd say, oh, we have 3 moles of this in excess and 1.5 moles of that in excess. So these would both be classified as an excess reactant. This one is the limiting reactant.
How much does CaC2 cost?
Questions on
You wanna
that?
buy some? Yeah, how do you get CaC2? Yes, that,
No
what is
comment.
it? No.
How much does it
That's not how
cost?
this works.
What's its price?
Yeah, what's the price going?
I think I bought my bottle for like 40-something dollars.
That's
Oh
ridiculous.
my gosh.
It's worth it to make a bomb.
Oh, who said bomb? I was talking about a cannon.
No cannon, different.
Yes,
Cannon
very
bomb,
different.
My bad. Depends on the type of lid you use.
Yeah,
Okay.
that's true. It's all dependent on the lid.
So that rice chart is to be used if you just need to compare mold, like you have lots of molds and you're trying to compare which one is used up first. Other problems, you may not have to know what's limiting because it's just given in the problem. For example, with this one. Oh, side note, we're skipping the next problem. We're gonna come back to it. It's a little out of order. So skip 4.5b, turn the page, and go to 4.5c.
Oh, mine was halfway printed.
Yeah, who's out of order here?
Okay, we'll come back to that one. Okay, so this problem says, once again, let's underline what we know and circle what we're trying to find. According to the balanced equation above, how many grams of this, so circle this, are needed to completely react with that? So underline what you know, circle what you're trying to find. Okay? Now, this is a case where we don't have to determine what's limiting because of how it's worded. I'm just trying to know, okay, if I have this much of one thing, how much of that thing do I need? We're not even caring about how much product is being made here. So let's go to our map and build our pathway.
No, this one seems
Okay.
like it should be pretty.
I'm starting in what? What's the thing that I underlined?
Well, you underline middle.
I underlined milliliters, which means I'm in solution. So this is the starting point of my pathway. What did we circle as our end goal?
Grams.
So I'm trying to get,
Oh no.
Over there though?
yeah, why is it over
Why does it
there?
matter which way you go?
Good question.
But does that mean that the maximum amount of things
Well, you
can
need
do
to
is
find the
4?
unknown.
Close, Taylor. Look one more time. You're on the right track there, so you're asking. Because technically this is 1, 2, 3, 6.
Oh yeah, that's true. I have like that.
Now, the reason why I went from here and not here is because of what it's asking. I'm not staying within, so what does it tell us we have liters of, that MnO4?
Yeah.
What is it that I'm trying to find?
It's actually KML.
Yeah. Camino.
But then there's another
Potassium.
K in the equation.
I'll explain that in a
I
second.
think KML.
What is the thing I'm trying to find?
Grams of.
Something different, right?
Oh.
But it's ClO2 minus.
So.
And it's
the
not
different
given,
subs.
so we have
Yes.
to.
The mole
Oh.
bridge changes the substance. If the question said, how many grams of KMNO4 is it? You'd stay on the same side. But when you change substance, you cross the mole bridge. Does everyone see the difference there? Okay, great question. Okay, let's set it up. So, my starting thing is, I do need to start in liters. So we gotta do kind of a pre-step here. So then in milliliters. So move your decimal and get it to liters. So it's what, 0.02 liters of KMNO4. Okay, so first step is to take what you're starting with and write that down. I need to change that first into moles of the same V. So set up your fraction. Liters goes on the bottom. Colors here. Moles go on top.
Okay, someone else do the math. I don't
Oh,
know.
22.4.
Ooh,
Oh,
close.
wait, no. No.
That's for a gas. What connects this one?
Later.
So what the problem give me a similarity?
0.2.
Now the question is, does the 0.2 go on the top of the fraction or the bottom of the fraction?
The bottom.
Oh, no.
I think.
Maybe.
Bottom is some weird.
So 0.2 capital M means
Moles over liters.
so 0.2 moles over 1 liter.
Oh, that makes sense.
Oh, yeah. So
So this goes in there.
Oh.
And then you make that into moles and
Questions so far? Okay, next step. So I'm going now from moles of what's given to moles of my new thing. So we're in moles of KMNO4. And I'm going to, need another marker here, moles of ClO2 minus.
Pretty close to the circle, by the way.
Oh no,
Oh,
the answer's
forgot
gonna
about
land in the
that.
circle. huh?
Yep.
Well, my next step, can I draw one more step?
yes. If you write it kind
It's
of
the size of your hand, right there.
If I squish it,
Well,
You
Oh,
can go a little
I
to the
think
right.
you have room.
can I go to here?
That's
No.
the middle of the circle.
Nope.
wait,
Yes.
it's basically touching like the back, like the bottom right corner of the mass in grams and the top left corner of moles given.
Oh,
Yes.
so I'll write my answer under.
Yes.
And this is to circle.
Okay, what connects moles to moles?
Moles.
The balance equation.
Balanced
equation.
equation.
Oh,
Now,
man.
bringing back Zach's question, I didn't forget about it. If you look at the balanced equation, there's no KMNO4.
Wait. Uh-oh.
It's just because the equation is written as a net ionic equation and K must have been a spectator.
Oh, dang it, potassium.
So what am I really just looking at for the ratio?
The oxygen.
So just find MnO4. Yep. So MnO4 has a 4 in front of it, so I'm going to put a 4 here. ClO2 has a 3. So it's a 3 to 4 ratio. Good so far?
And then
Oh, yeah.
Okay, so I've traveled to here. Now we're going there.
mass of ClO2.
So mole of ClO2 to grams.
Okay, let's see.
Very good. We're looking at a
This is the
periodic
most
table.
satisfying color.
We get some answer.
35, 4,
Plus 32 to
67.453. About.
I mean, technically,
Technically,
it's
it's
just like
less.
0.452. Something like that.
Okay, perfect. And then plug it into your calculator.
There we go.
Go, Sailor.
Dude, I'm so cool. I know
Yeah, we're really proud.
Whoa.
times 3 times 67.
So we get an answer, let me know.
You know, we're gonna put parentheses around this whole thing. I don't trust it.
Side note, how I type in stoichiometry, everybody,
0.202.
I don't type in fractions, because to me that just takes too long, or more typing than I feel necessary. So this is how I would actually type it in my calculator, is I would type the starting D.
Yeah, that's how I did it. I got
Anything on the top, I just hit the times button. Anything on the bottom, I hit the divide button, and if it's a number 1, I just don't do anything. So this is how my calculator would look, is I do 0.02 times 0.2 times 3 divide 4 times 67.45. That's how I type it in. Some people times all the top and then times all the bottom and
Aha.
divide them.
That is me.
That's an extra step in my book. And that, once again, I don't like plugging in a whole bunch of fractions. So what do we get for an answer?
0.20235.
That's a lot of numbers.
20.
0.20.
Oh, I did it backwards. Okay, grams of ClO2. Questions on setup or anything there? Okay, with your table, buddy, let's have you try to solve 4.5D. When you have an answer, raise your hand and I'll come check it. Or if you get stuck, ready, set, go.
Find 8 grams of potassium.
My little sister's talking to her.
So if you make
So she's like,
Okay.
little brother. And she goes, why? She's like, well, when I wear it, it's hungry.
Oh no, this is coming down.
And it's 22.
Just don't wear it with masks. You know, like it's not your mask. Just wearing the mask.
Oh yeah, 'cause so.
No.
Well, I feel like sometimes we like find a spare one, like when
Oh,
someone
yeah,
else
that's
has one. You wouldn't be trying to, unless you don't want to work.
So how many moles are in it? That's 32. Wait,
It's totally up to you guys, but if you honestly want to do it
30.
here and sit here instead, or you could sit there.
Well, first we have to do
I can't believe it.
Oh, that's true, Landon does sit
I don't
here,
have
he's
it.
just been gone.
Thing printed weird.
You could just migrate to wherever it's okay.
Potassium
We
must
have
be decomposed.
O2.
Okay, so we need grams of potassium
So would it be 3 and 2?
must be decomposed to generate 1 liter of oxygen. Okay, that makes enough sense. So what we're finding is getting a reaction. Okay, so
Wait,
let's
does
see.
moles of O2 have to go under?
Yeah.
Oh, you
Yeah,
just
so
said
let's like I keep going back.
3 moles.
It's just
Oh,
And then
let's see. So we got
2 moles.
Once you have an answer, raise your hand, I'll count you get a thumbs up or the try again.
thumbs up or try again. If you come to the answer wrong, I would request a thumbs down.
Yes.
3, is that, it's 39.09. That's what I was saying, I just told you that.
Okay, so liters. We're doing liters to
39.09.
right?
So,
Okay, so we get 1 mole
Yeah, on the bottom.
So are you getting the grams of?
yeah, I'm getting the grams.
Okay.
It's 122.
And then,
549.
so we're from liters. Okay, now we gotta go to moles. What are we even? Okay, so O2. So 2. Well, yeah. I mean, it could be either way. Yeah, either way. Anyway, So it's just 3O2.
I was just thinking of the first part of it. I was just thinking
Wait, what?
Oh, I'm on the wrong.
What are you doing?
Oh, no.
What are you doing?
The 2 KCl of 6. And then let's see. We need to
That's
make
like why
that
my colors,
grams.
the diagonals are always the same color,
It's 2
because they should always be the same color.
And then we need to make grams. So let's see. Yeah. This is yeah.
So what about the? Oh, we only
Yeah, you always go off your structure. That and
Potassium weighs. Someone give me a periodic table.
yes, have a smiley face, guys. Hold on.
Okay, let's see. So Cl. Okay, here we go. So A is 39.
Bye, Nolan. I guess I'll see you after Christmas. Okay.
Peace out.
We'll see you all the time.
Enter 106.53.
Like on the bottom of the bottle.
On the
Let's start homework.
Wait.
Part of it.
What now?
Part of it.
Never
Oh,
did
yeah,
one.
the other one.
Yay.
Once you get a final answer, let me know.
Wait, what was the math?
Right out balance chemical. So,
It was 106.53 times 3. Okay. I got my final answer to be 0.12.
Did I do that right?
Okay.
wait, solvent.
Are you good? That's not good.
Okay, now balance equation of solid copper metal. Okay,
Everyone's like,
C,
and I have a black eye too.
And you have a black eye too, yeah. Oh,
two,
Oh.
silver and
Wait, how did
nitrate.
you get
Oh, I did my math wrong. I did 2 instead of 3. Wait, no, I did. Yeah, I did. Only did 2. I only did 2 oxygen guys.
How dare you portray us like that?
Silver is what is silver? It's AG or AU?
Okay, so it's 122.53.
So AG and then what we do two, AGT. It's a minus.
Bye, bye.
And so would we have to put parentheses around that and do two?
Oh,
Just
yeah,
like
that would mess things up.
The two? Or we can make
Maybe
it just
double it
AG2.
on accident?
Copper under.
Those phone calculators like
Copper's
save
above.
numbers, I find.
What?
So it'd be copper two. It's copper, like metal's always
Perfect,
two.
we actually do get 2 sig figs, but I know we rounded to 4 because of it.
Okay, and
So the
AG2.
0 counts as a sig fig because it's after the number and after the decimal. So you do actually get 2, but you're set up perfect for the stoichiometry, so have a smiley face.
Wait, metals suck. Why do we have to? Metals
Have a smiley face. Okay, any questions so far?
What is the charge of AG2? Wait, is it like the one that you change like AG2?
AG is actually always +1
Oh,
every
let's
time.
go home. So AG just works. Oh.
Alright, so we're done.
Always.
You got 3 points.
Okay, and it produces copper two.
Might just be because when I compare it to I
That
use
just
for my
makes it
math, I just
Nitrate
thought
too.
The 2 in copper just
I guess
is the
that's
charge.
so otherwise you guys look awesome.
And
so
so-
I'm sure it's
And then
just that.
nitrate has a 1 charge, so it would be 2 copper.
Yeah,
Which means we're gonna have to have 2.
NO3. Well, let's just do that after we write all this out.
Okay, I think I looked over
here's
everyone's,
so
or you're
AG2.
almost there, but here's the setup for the problem and the answer.
So we're gonna have
Um,
two.
Any general stoichiometry questions so far?
Silver
Add one little
Dude,
twist.
this is really all their. I thought this was the whole thing.
Oh
I'm
my
gonna
gosh,
die.
you would have lost,
But
I would have lost this
then there was.
So you have everybody's.
Then,
Then there were four.
then I'm not
Okay.
dead.
Everyone
Oh.
flip back for me really quick
That would have been a sad day.
to the one we skipped. Go back to 4.5 feet.
Oh, man.
Okay, I'm gonna come to this map actually. Okay, let's read this problem and I want to point out what's different. Because it's important to recognize when a problem changes how you have to solve it somewhat. Okay, so we're looking at 4.5b. It says the reaction that's given is used to produce electricity in a hydrogen fuel cell. Suppose a fuel cell contains 150 grams of hydrogen and 1,500 grams of oxygen. How many grams of water can form? So, as always, you should underline what's given
75.
and circle what you're trying to find.
75.
So what is it this problem wants me to find, everybody?
Yeah, I know, but the
Three
hydrogen
under water. So
basically.
your
Yeah,
end
hydrogen is
goal.
a one.
Wait, so is the answer just 75
It's gonna be around 75.
or 7?
We're calling it right now. It's gonna be around 75.
Wait, but what if the oxygen weighs so much that it can't even?
Wait.
Oh wait.
We're calling it max.
Okay, so I'm trying to get
Perfect sense to me.
to grams of something.
I have one. Thank you. Oh.
Okay, get your attention here, everybody.
I'm the trash table.
The difference is what's given this time.
2 grand.
Two separate amounts. When you're given two separate amounts, you have to figure out which one, if either, limits the
I did.
reaction.
I did.
Because if you just say, oh, well, this is the one, you may, once again, like our problem, think you're making this much, but you won't because you'll run out of the other substance. So what we have to do is we have to compare them, but you can't go off of grams. Just because we have, because what, we have 150 hydrogen and 1,500 grams of oxygen.
Can we just add them?
Oh wait, each one is
So
each 2.
by the grams, a lot of people say like, oh, well, we have a lot more oxygen, so this must be limited.
Wait, it's not 75. I did some quick math
You don't know why
in my
though.
head.
Okay, close your mouth here.
You should have Winston explain why oxygen is limiting. Because he says he knows.
Wait.
Do you want to, Winston?
No, he has to. He has to. You have to, Winston.
Because it has a lot more weight than hydrogen. Like,
So it's that we go atom by atom, right? And having this much oxygen doesn't exactly mean you have more of it when you go down to the molecular view. Because comparing weight-wise, how much does hydrogen weigh?
Only one.
Technically 2 because it's H2, but yes, right? Compared to how much does O2 weigh?
32.
32. So first step is you gotta get them moles to moles.
Well, I know, I just didn't. I know. I appreciate your, Winston, if you're so smart, why don't you take the test sometime?
Oh, no.
Not too far.
I'm
Okay.
sorry. I'm sorry.
But then we still have something else we also have to look at. So we're down to the molecular view, but now we also have to look at the equation because we don't use them always in an equal 1-to-1 ratio. In this example, what am I using?
1 to 2.
Right? I need to have double the amount of hydrogen for the amount of oxygen. So we need to know according to the ratio how much water can be made. So I'm going to take it another step for both of them and say, okay, well, for every 2 moles of H2,
92.
it makes 2 moles of water.
Which is just.
But for oxygen, for every 1 mole of oxygen I use, it will make 2 moles of water.
No pen, don't die me now.
what do we get?
Wouldn't the one on the top be 1 over 1?
Yes. I did 2 over 2 because that's what the balanced equation says, but it is the same as 1 over 1.
Oh, I see.
Okay, so this one we get 74.25.
Wait, so is the answer actually 74?
Oh, yo. Well, then you have to calculate the.
No, the oxygen is
oxygen.
92, I think.
Isn't it 2.26?
So does that mean it's gonna end up being
Say that
like
again.
150?
Please have us be right over.
Please have us be right over.
Should this be a 6 instead of a 5? Thank you. Okay, so then we get the next one, and this one ends up being,
Dude, we
That's
were
kind of
freaking
close.
right. You're
Yeah.
so it actually is
It's
really
74.
close.
That was a total guess.
Okay, now this isn't our answer.
You have to add them or something, right?
What does this tell me right here?
How many it can make?
So this says if all of this is used up, it will make this much water.
Oh, so which one's
If
limiting?
all of that is used up, it will make this much
So the
water.
H2 is limited.
So which one do I focus on?
Oh,
H2.
Winston.
The lower one. Because once this is made, this is gone, I'll never be able to make that much. So this is my excess. This is my limiting.
Oh, good.
Now the limiting, because the final answer doesn't want moles, it wants
Grams.
grams. So for 1 mole of water,
You should.
18.02 grams
Heck yeah, man. Good for you.
to get your answer.
74. 18.
Oh wait, excess has a C in it, dang it.
1,338.1652.
Nice. He's gonna remember all of those numbers you just said.
I don't think we need any decimals.
Say, I didn't give you very many sig figs either on this problem, I don't think. Technically, we only had 2 sig figs.
Uh-oh. So
How would I round this to 2 sig figs?
would it be just 1,300?
But Winston is gonna destroy us on the test. That's all I know. I'm gonna get like a
There's your answer.
30%. He'll get 100. I'm calling
GH2.
right now, guys. Oh,
Okay, the lab will have you practice some more of these limiting ones as well. And then your other assignment is worksheet 4.5. There's an extra credit assignment course that you can do as well. That is open all the way till the 17th.
I love extra credit.
So I would focus on corrections first, and then you can do the extra credit if you need to.
Please not be
Okay?
done.
So that was like kind of perfect.
Yeah.
Yep, see you
Yeah,
there.
see, he's smoking.
Yep, see you there.
Hey, did you